All right, well, welcome everyone to the Introduction to SQL Server on RHEL and Open Shift session. I'm Travis Wright. I'm one of the program managers on the SQL Server engineering team at Microsoft. And I'm happy to be here at Red Hat Summit. I actually came to Red Hat Summit last year. Great event. It was the first time that we'd sort of demoed SQL Server on RHEL publicly last year at Red Hat Summit. And a lot's happened in a year. We've made some great progress, and I'm really excited to be able to demonstrate to you guys today the progress we've made towards getting SQL Server available on Linux. So I thought we'd just start with kind of a quick introduction to SQL Server. I know not everybody from the Linux world is familiar with SQL Server since, well, you guys haven't had it for all these years, right? So I thought we'd just kind of give a quick overview of SQL Server, what the value prop of it is, and then I'll just spend the rest of the time just doing demos. And we'll just kind of walk through some things. Feel free to ask some questions as we go along the way. It's going to be an action-packed session because we only have 45 minutes. Normally I spend like an hour and 15 minutes just doing an intro. So hopefully we'll have some just good times here. So let's see how it goes. So let's just kind of dive right in. If you kind of take a look at what's happening in the world today, a lot of the things that are around us, like whether it's the stars or the microorganisms in our planet or biology, all these things are being sort of encapsulated as data points now. And it's really interesting to see all the different technological advancements that are happening because of our ability to capture data and reason over it. And SQL Server plays a very important part in our technological advancement by giving you the tools and the data platform that you need to be able to capture a very large amount of data, any type of data, using any programming language, reason over that. And it's really exciting to be bringing that now to the Linux world, where a lot of things are happening in the scientific arena or the education arena. It's just amazing to be able to think about sort of the expansion of the capacity of humans, given SQL Server to now also be available on Linux, right? So I'm excited to see what's going to happen with this. So let's kind of dive right in here. SQL Server 2016 was released last year about this time. And for those of you who don't know, SQL Server 2016 for the last couple of years has been rated by Gartner as the leader in the database Magic Quadrant, for the relational database Magic Quadrant. And not only that, but it's also the only database that is in the leader quadrant for all three of the database-related Gartner MQs. So that's the RDBMS, where we are the leader, and the BI Magic Quadrant, and the Analytics Magic Quadrant. So a couple other kind of interesting points about this. The National Institute of Standards and Technology, they have the really fun job of like keeping track of all the vulnerabilities that happen out there. So you can sort of envision these guys sitting there, and every time they hear about a vulnerability, they like write a 1 on the chalkboard, right? Super fun job, okay? But these guys keep track of vulnerabilities, and SQL Server for the last 7 years has had the fewest number of vulnerabilities out of all of the commercial database and even open source databases in the market today. It's also the highest performing data warehouse. So we publish benchmarks to TPC. It's the fastest. We hold the number 1, 2, and 3 benchmarks for data warehouse. One other important thing about SQL Server is that it offers you all the capabilities of any other database out there or more, but at a fraction of the cost. So if you think about just in terms of the BI costs, you can see here that Microsoft is like, what is that, like a 12th of the cost of Oracle for BI, right? And in fact, depending upon what bundle of features you put together, in general, SQL Server will cost you about a 12th of what Oracle costs you. And that's because everything is just built into SQL Server. There's just one license. Everything from the relational database to BI to analysis services, integration services, they're all just included. There's no extra cost for things like in-memory OLTP. It's just built in. Now, we also have done something interesting recently with the SQL Server 2016 release, where we acquired a company called Revolution Analytics. They are experts in the field of R and doing analytics, and we built that right into SQL Server. And we just announced that in SQL Server 2017, we're expanding this notion by adding Python support to SQL Server. So you can run R scripts or Python scripts directly inside of your T-SQL queries inside of SQL Server. So what this really means is that we combine the best of your traditional database type workloads as well as analytics into one database engine, right? So it's all just there in the box, ready to go. And this type of solution is powering some of the interesting things that we just talked about, right? So the Sloan Digital Sky Survey is out there, and it's scanning the universe and cataloging all the stars that are available. It's terabytes and terabytes of data. You know, stars just used to be like pretty things in the sky, but now we can actually codify those stars and everything about them into a database, and that's driven by SQL Server. SQL Server is being used to do cancer research. It's being used to increase crop yield. So there's really an infinite possibility of what you can do with the database that offers you the ability to store any type of data using any programming language, and it's just all right there built in. Now, in general, businesses are embracing choice. There's, in sort of this modern technology world, there's just a diversity of technology, and there's more and more every day. And it used to be that we tried to think of things as like, you know, we have a Microsoft stack and we have an open source stack. Well, it's not like that anymore, really, right? There's no Microsoft stack anymore because Microsoft is embracing this idea of choice and giving customers the option to choose whatever technology it is that makes sense for them. And so now there's just a collection of different technology, and you can pick and choose whatever makes the most sense for you based on factors like cost or your expertise with a particular technology and so on. And Microsoft is all about enabling that type of choice. We want to let you choose to program in any language you want with SQL Server. So we've been improving the drivers for every programming language out there. We want to be able to store any type of data. So you can store document data in SQL Server. You can store binary blob data. You can store IoT type data. It doesn't really matter. Any type of data can be stored inside of SQL Server. And in fact, in SQL Server 2017, which is coming out later this year, we also introduced the idea of being able to store graph data in SQL Server. So you really don't have a need to have a special graph database if you have graph type data. You can store that in SQL Server and query it and store it using graph semantics. Now, in general, Microsoft is embracing this idea of choice. So as you know, about a third of the virtual machines in Azure are Linux, right? .NET is now running on Linux and Mac OS. It's open source. You've got R, which is a server that Microsoft provides, open source, ready to go. So it's all these things that Microsoft is doing. And in fact, Microsoft is the #1 contributor to open source projects on GitHub. This is sort of the new Microsoft, right? And SQL Server on Linux is just another step in that direction, about giving customers the choice of where they want to run their SQL Server database. So with SQL Server 2017, we're introducing support for Linux and for Docker containers. As I mentioned, we're adding support for graph databases. We're adding support for executing Python in your database. And we're improving the performance even more. So as I mentioned, SQL Server is already the fastest database on the planet. We're making it even faster. And I'll show you more about that here in a moment. So how did we manage to bring SQL Server to Linux? It really didn't take that long. People typically think, oh, they must have had some poor souls that were over in some building in the corner of campus that were sort of transcribing code in order to get it to run on Linux. But that wasn't really the case. That wasn't the approach that we took. What we actually did was we took some technology that's been in SQL Server for a long time called the SQL OS. And the SQL OS is a layer inside of SQL Server that's been there since SQL Server 2005, which is responsible for memory handling, for processor scheduling, for disk and network I/O, and so on. And SQL Server has optimized that hardware interaction because it has a specialized workload, right? So we don't want to depend on a general purpose operating system like Windows for that, so we brought all of that type of hardware management inside of SQL Server itself. Now, Microsoft Research also had a project a few years ago called Drawbridge. And Drawbridge was a project that was intended to provide process isolation. So think of it as sort of like a container, right? The idea being that we could be able to run processes in isolation in Azure and get higher density for our compute in Azure. Now, this particular project was sort of shelved because Docker was coming on the scene. It was very popular, and so it was like, okay, we don't need to compete against that. Let's just go with Docker, right? Now, but we took that project and we learned something interesting from that, which is that they were able to map all of the API calls in Windows down to about 50 application binary interface calls. So you can think about the huge surface area of the Win32 API all boiled down to just these 50 ABIs. So what we did is we combined SOS and the Drawbridge project into what we now call the SQL Platform Abstraction Layer, or SQL PAL. And SQL PAL allows us to have SQL Server running on top of a very small number of Windows binaries. And for all intents and purposes, SQL Server thinks that it's running on top of Windows. And we don't really have to rewrite a lot of the code. But for those code paths which are performance critical, right? So disk and network I/O, for example, there we wrote more direct code paths through the infrastructure, right? So we don't have to always go through the Win32 APIs. We can bypass those for things that are performance critical. So the result of this is that we now have the relational database engine running on top of SQL PAL, and we didn't have to rewrite it, right? It's mostly just the way it was. So that's good in terms of code quality, because every time you go and rewrite a bunch of code, it's, undoubtedly some engineer is going to, fat finger something and end up with a bug. So we didn't have to rewrite most of SQL Server. And the other benefit is that now we have a consistent platform abstraction layer, which SQL Server on Linux runs on today, and in the future, SQL Server on Windows itself will also run on top of this platform abstraction layer. And what this means is that the same code will run in both places. And if you go and look at a preview release of SQL Server 2017 now, and you run select add version on SQL Server on Windows, and you run select add version on SQL Server on Linux, you will see that it's the exact same build number. It's exactly the same binaries. We ship it on both platforms. And therefore, anytime we fix a bug, it's fixed on both platforms. Anytime we introduce a new feature like SQL Graph, it just shows up on both platforms. In fact, SQL Graph was built by SQL Server engineers that do all their development and testing running SQL Server on Windows, but it just works on SQL Server on Linux as well. So today we have the relational database engine running on top of the SQL PAL. The engineering team is also now already at work on bringing integration services to run on top of SQL PAL, and that will be released at some point in the near future. And we're also bringing our services on top of the SQL PAL as well. And then depending upon customer feedback, we'll bring things like analysis services and reporting services as well. Now, the first question I always get asked after I introduce this concept of like a SQL PAL is like, well, what about performance? You guys introduced a new layer here. What's the impact? So we just, like 2 weeks ago, I think, published our first benchmark for SQL Server on Linux. And we chose to partner with RHEL and with HPE to publish this benchmark. And the first benchmark shows that, in fact, the performance of SQL Server 2017 on RHEL is awesome. It's what you would expect from SQL Server. In fact, we increased the performance by 5% and decreased the cost for performance by 6%. And this is on comparable hardware. In fact, the test running SQL Server on Linux was using half the RAM that it was using with SQL Server on Windows. And of course, anytime somebody that's like a RHEL fan sees this slide, they're like, oh, I knew it, Linux is faster than Windows, right? How many of you guys thought that when you first saw this slide, right? Yeah, OK. So there's one subtle thing here that's easy to sort of ignore, which is that this test is a comparison of SQL Server 2017 on RHEL versus our last benchmark, which was SQL Server 2016 on Windows, OK? So it's not that SQL Server on RHEL is faster. I'm here to tell you that it's not. It's that SQL Server 2017 is faster than SQL Server 2016. But what I can tell you is that the performance of SQL Server on Windows and SQL Server on Linux is almost exactly the same. And this is what you would expect. At the end of the day, it's x86. It's just binary code. And it all just boils down to assembly. Okay? And so when we run it on the same hardware, it's almost exactly the same. And that's our goal from Microsoft's perspective, is to have the performance be comparable on Windows and on Linux, right? And to deliver that really high-end performance that our customers expect, whether they're running on Windows or on Linux. But still, really cool to see. I'm sure all the RHEL fans are like, yeah, But, and the Red Hat guys actually published this on the RHEL blog a couple weeks ago. So hopefully you guys saw that there. But it's really exciting to see, and we're excited to be partnering with Red Hat and HPE on this. Now, this slide is a bit of an eye chart, so I included it here in the deck mostly just for completeness, and people can refer to it later. But the idea with SQL Server 2017 on Linux is that we're going to deliver the database engine, and that will be the scope of the first release. So it won't include things like integration services, reporting services, analysis services, and some of these kind of peripheral services around the database engine. Will be focused primarily on the database engine. Now, within that database engine, there's a huge feature set. And because of this SQL PAL, we're able to deliver almost the entire feature set. So things like in-memory OLTP, or column store, or partitioning, or JSON, or XML, or graph, they all just work on SQL Server on Linux. There are a few exceptions. Things like file table doesn't work because there's some dependencies there on the Windows file system that we have not been able to implement for the Linux side yet. Some things like polybase or StretchDB. So there's a couple features that aren't there yet. We'll add those over time. Here's just kind of another list of things that you can take a look at. But kind of the key thing to take away here is that we're almost done. In fact, the last feature we have to do is Active Directory integration. And the engineers just got it working last night. And I'm going to demo it to you today at the end of the session. And hopefully it works. Right? But that's actually the last feature we have to do for this release. And from here on out till general availability, it'll just be all about stabilization and responding to customer feedback. So we're actually pretty much done with this first release. OK, so a couple notes on some key feature areas. So with security, we have transparent data encryption. This allows you to encrypt your data at rest, whether it's an operational DB or it's also encrypted at the time that you back it up, so it's always backed up and encrypted. We have cell-level encryption. We've got always encrypted, which is an interesting feature that allows the client-side application, if it's using one of our enhanced code libraries, which is ODBC, JDBC, and .NET right now, to encrypt the data before it goes to SQL Server so that the data is encrypted inside of SQL Server, and the only thing that can decrypt it is the application client. It's kind of an interesting feature. Then we also have access control, so you have the ability to log in with SQL logins. As I mentioned, you'll be able to log in with Active Directory user authentication as well. We've got very granular role-based security built into SQL Server. That same functionality exists with SQL Server on Windows today, carries over to SQL Server on Linux. We have some other features like row-level security, dynamic data masking, which allows you to mask data when it's returned by SQL Server. So if you want to mask a social security number or an email address or so on. And we also have fine-grained auditing. So you can keep track of every change that happens to anything in the database. Now, the area of high availability is a huge area for SQL Server. So this covers everything from your typical VM level high availability. If you want to be able to vMotion your servers around, we support that. Backup and restore is supported, of course. You can back up your database on SQL Server on Windows and restore it on SQL Server on Linux. If we have some time, I'll show you a demo of that today as well. Then we move into some other areas, like you can use the SQL Server agent to do log shipping. So you can ship the log off to a remote location and have that be replayed on the other end. So that's good for a disaster recovery scenario where you need geo redundancy. And then we move into scenarios like failover clustering with shared storage. So with failover clustering for shared storage on Windows, you would use Windows Server failover clustering. And those are services that are built into Windows. So what do you do on the Linux side? Well, we partnered with Red Hat, and we talked to a bunch of customers. And the feedback that we got from everybody was like, oh, Pacemaker is the way to go on Linux. So as a reference implementation, we've built our high availability solutions to use Pacemaker as the clustering technology. Now, the design on Windows is very integrated with SQL Server. On Linux, because there are multiple high availability solutions in the Linux market, we decided to take a more open approach to it. And there, you can plug in lots of different high availability solutions. It could be Pacemaker, could be Zookeeper. And we're working with some additional partners that will offer some solutions in this space, and we'll have some more to talk about that later. The idea is to have a more open architecture that allows you to plug in whatever high availability solution makes sense for you. Now, we also have support for always-on availability groups. Always-on availability groups are SQL Server's way of providing high availability through replication. So instead of having shared storage, you replicate the data to multiple nodes, and each node has its own copy of the data, and one of those nodes is the master. And this is good for high availability scenarios where you want to replicate that over, and then you want to fail over from one node to another. And you can do that automatically with Pacemaker. But it's also good for read-only scale-out scenarios. So you can actually replicate the data out to multiple nodes, and you can then have what's called a listener, which your applications can connect to, and they can indicate their intent is to do read-only transactions, right? So they'll come in, and they'll be redirected off to one of the read-only nodes in the cluster, and they will run all their transactions there. This is also great for scaling out your backups, for example. So instead of doing a backup on your primary, you could actually do a backup off of one of your read-only secondaries. And this is also interesting because you can do this type of scale out in a clusterless fashion now with SQL Server 2017. So you don't have to have a cluster. If you just want to do read-only scale out and get some redundancy that way, go for it. And then so as we went out and we talked to customers about high availability scenarios, I kept having people ask me like, well, can I have a Windows node and a Linux node in one always-on availability group? I was like, dude, that's weird. Why would you do that? That's just weird. Why? And then I got to talking to people about it, and they actually came up with some interesting scenarios why you might want to do this. So the first reason was SQL Server on Windows migrations to SQL Server on Linux with minimal downtime. So this is where all of you in the room are like, yes, finally we can get rid of those Windows servers and get all the SQL servers over on Linux by having high availability groups, and we just replicate the data across, and then we just fail over and we're done. So we're like, okay, that's an interesting scenario. So we went and built it, and it works. So you can now do always-on availability groups which span across Windows and Linux. It's weird, but if your goal is to migrate, you're good to go. Go for it. Now, another scenario that people think about here is this idea of operating system level redundancy. And I don't think anybody else in the industry offers this, but the idea is that you could have these always-on availability groups which span Windows and Linux. And then if you have some kind of zero-day vulnerability that comes up on Linux, never happens, right? Or on Windows, could happen. Then you could fail over from one OS to the other, or back, right? So it's kind of an interesting idea, this OS level redundancy. Let's see, there was one other point about HA. Oh, very importantly, this type of configuration with Windows and Linux in one availability group is not an HA solution, right? Because there's no cluster manager that spans Windows and Linux. This is really just for migrations or more manual failovers in a scenario that I described. All right, so then people ask me about tools. Okay, so what are we doing about tools? So SQL Server Management Studio has been the de facto standard tool for SQL Server forever. And we will not be bringing that to Linux. There's just too much baggage there to be able to bring that to Linux, right? So we're taking a little bit different approach there. The first thing is that we've made all of the command line utilities that people are familiar with, like SQL CMD, BCP, SQL package, and we've made those all native and they run on Linux or on Mac. And we've also taken the Visual Studio Code GUI, right? So Visual Studio Code is Microsoft's cross-platform code editing tool. It's a kind of a lighter weight sibling to Visual Studio, but it's cross-platform. And we've created an extension for that called MS SQL. We're really creative with our names. And you can just pop that extension into Visual Studio Code, and I'll show you guys this here in a minute, and that allows you to connect to SQL servers, whether they run on Windows or on Linux, and execute some queries. You get syntax highlighting and IntelliSense and some cool features like peak definition and so on. And all that's just built in Visual Studio Code. You can run it on your Mac, on your Linux machine, or on Windows, connect to Linux or Windows, and it gives you lots of flexibility that way. So it's really great for developers that are using a code editing tool like that. But what about the DBAs? You know, they're not necessarily writing code every day. They just need a tool that they can use to execute some queries, maybe set up an always-on availability group, check on the state of a few things, set up some logins, whatever that might be. So for that scenario, we're now working on a new cross-platform database admin GUI tool. And the code name for this project is Carbon. We will be releasing it here pretty soon, and it will be super cool. So it's cross-platform. It'll look a lot like Visual Studio Code in terms of the look and feel. And you'll get all the same benefits of being able to author queries and execute them with syntax highlighting and IntelliSense and so on. But it'll also have some of the database admin GUI functionality built into it as well. And both the Visual Studio Code extension and this Carbon project will be open source projects. The Visual Studio Code extension is already up on GitHub. And the Carbon project is already on GitHub, but it's private right now. We'll flip it to public once we make the first release. So those are kind of the tool sets. Now, we've also been doing some testing with third-party tools like JetBrains, DataGrip, or dbeaver, Eclipse, all those different tools that people use on different platforms. They just connect to and work with SQL Server on Linux just fine. All right, whew. That's the end of the slides. You guys ready for some demos? Check that out. Maybe I can take a couple questions while I'm getting set up for demos. Any questions? Yes, sir. Yes, so the question is, did we have any problems with // in the paths for files and so on. And yes, we did. Yeah, so we had to work through all those things, but those are all resolved now. And you can use native Linux file path syntax in your T-SQL queries. And even in SQL Server Management Studio, you can browse the file system on a Linux machine just like you would on a Windows machine, right? So, OK, so let's get started with how do you install SQL Server on RHEL. So if you go up to our docs, we have some docs here. This is all you have to do. You just pull down our repo configuration file, store it in your repo directory, and then you run sudo yum install ms SQL Server. That's it. You got SQL Server installed. We tried to make it harder, but it just wasn't, so sorry. Then there's one command you have to run to configure things, which is ms SQL conf setup. So let's go ahead and just kind of test this out here in a VM I have locally. Now, what am I doing? OK. All right, so I've got a local VM here. Now, I wasn't sure about the network, so I pulled down the RPM package here locally. So this is also kind of an interesting demo to show you don't have to necessarily install from our public package repo. You can pull it down and copy it over to a server and install it manually, right? So I can just do yum install ms SQL -y, boom. Now, when you're installing this from the public package repo, depending on your network connection speed, you can download and install SQL Server in less than a minute, just like that. It's really fast. How many people have installed SQL Server on Windows? Yeah, how's that? 3.2, I think it is, gigabyte download, and then you've got, I don't even know, I think it's like 42 clicks or something like that. We figured out how many clicks it was the other day in the wizard. It was like 42 or something. So, but you can see here that it's just a yum installation experience using an RPM package. It's the same on the other distributions of Linux. You can use the package manager that's native to those distributions. But that's it. You've got SQL Server installed now. And the next step that you do is you run ms SQL conf setup. So we'll just go opt ms SQL bin ms SQL conf setup. Now, for our Windows administrators that are going to be coming over to run SQL Server on Linux, it's going to happen. We wanted to make them feel comfortable when they came over to here. So we built them a nice command line wizard. You guys ever heard of a command line wizard? It's really cool. You can go in here and you can answer its questions like, yes, I accept the license agreement. Here's my password. OK, now it's configuring SQL Server and I'll be done. So first point here. We have to ask for the license acceptance. We tried to get the lawyers to say that it was OK not to, but it just is, right? So, and we have to ask for a password because we have to be secure. So those are the only two things you have to provide to install SQL Server on Linux, right? And now you're done. So now everything's set up and configured, ready to go. Now, you might be like, that's a little weird having like a wizard type experience at the command line here. But don't worry, because we have it all set up so you can use environment variables or a configuration file. So I can come in here and I can do something like accept EULA equals y, say password equals econ900, and then I can run ms SQL conf setup. And just by passing those environment variables on the same command line there, it'll set the environment variables. The SQL Server engine, when it starts up, will look for the environment variables to be set, and it'll do the magical things, and it'll just come up and run. So this is a way that you can do a one-line install and configuration of SQL Server. You can use an ms SQL conf file as well if you want to be able to have all of your configuration settings stored in a file. You just drop that file into the right place, run ms SQL conf setup, and you've got SQL Server up and going. So this is the way that Linux people do it, right? So you've got your Linux way, you've got your Windows way. You sort of pick your way, but there will be no GUIs, right? There are no next buttons. So we're going to try to make it as Linux native as possible. All right. So now let's take a look at a couple other things here. Right. So will we introduce a GUI for installing SQL Server on Linux? Unless we have overwhelming feedback from customers, no. Feedback from customers so far has been, this is awesome. This is exactly what it should be. Thank you very much for doing it the right way, Microsoft. And we will not be building a GUI for Linux, right? Hopefully everybody agrees with that notion. But OK, now, to make things even easier, because I know everybody likes easy. We have published a image of SQL Server on RHEL up in Azure. And you can just go up here, click this, click Create, and it'll go through and ask you a few things about what size your virtual machine should be, what you want your SSH login password to be, or you're going to use your, your keys or whatever. So just ask you a few basic questions, and you'll have a SQL Server running on RHEL up in Azure. And we'll continue to improve this experience, but as of right now, you deploy this thing, SQL Server will be pre-installed in it, then you just run MS SQL conf setup, pass in your license acceptance and your SA password, and you have a SQL Server running in RHEL. Now, we did an interesting thing here where we partnered up with Red Hat, and we got them to be very generous and offer this image without the Red Hat subscription premium costs associated with the virtual machines you deploy using this image up until general availability. So you can go up there and you can play around with this and use this without the additional Red Hat subscription premium cost. You only pay for compute with this particular VM image. So give that a try. It's the easiest way to get going with SQL Server on RHEL if you have an Azure subscription. OK, but now, containers. They're the new hot thing, right? So we have published, let me just show you this real quick. So we've published an image up on Docker Hub. It is an Ubuntu-based image. And you can see that it's been downloaded, where are we at now? 964,000 times in about 5 months. So it's been a very popular way for SQL Server to be acquired. And it's just so easy. I just love Docker. I pretty much only work with Docker now. I don't do VMs anymore, unless I'm doing demos like this. So publishing an Ubuntu-based image up to Docker Hub is really easy because there's no license, there's no lawyers. You just push it up there, right? But with RHEL, we got to be a little bit more careful about things. So I can't push a RHEL-based image up to Docker Hub, but I can push a Docker file up to my GitHub repository. So if you go to my GitHub, you can find a Docker file that will show you how to build a RHEL-based container image. And I've got basically the same thing here. Let's just kind of pop this up. So basically all this does is it goes out here and it uses your subscription manager to go and log into your subscription, and it'll update the packages, it'll install SQL Server, and it'll install the SQL Server tools, and then it will start the SQL Server process, right? And that's it. So true to the container pattern, when SQL Server runs inside of a container, it's just the SQL Server engine process. That's all that's there. Now, I can go out here and I can build an image. So I can do Docker build. Oops, wrong one. Docker build. All right, so Docker build dot boom. I already have all the images built, but you can see how it kind of works there. I can do Docker images. You can see that I have an MS SQL Server RHEL image that's already built here, right? Now, if I want to, I can start using this image for things. So let's, I have a file here. Let's do, so I've got this wwi.back. You guys can't really see that very well. So I've got wwi.back. This is Worldwide Importer's backup database. This is our sample database that we provide for people to kind of play around with. It has all of the most advanced features of SQL Server running inside of it. And what I'm going to do is I'm going to start up a new RHEL-based container, and we're going to restore that backup to that container. So we'll go docker run -e accept EULA. There's that license acceptance thing again. But you can see how things work consistently, right? So I've got the environment variables behave the same way whether I'm running in a VM or a container. So we'll map the ports, and we'll map the backup directory inside of the container there, and we will run MS SQL Server RHEL. OK, so there you go. Now I have a container running. So docker ps. You can see there's my container. Let's docker exec 89 -it 89 bin/bash. OK, so now we're inside the container, and we'll go into the backup directory inside the container. We'll ls. So there's our backup file. So the backup file is on the host, but it's been mapped into the container. So now I want to show you the Visual Studio Code extension. So the Visual Studio Code extension is accessed by opening up the command palette, and you type SQL, and you can see all the different commands that are available. So in this case, I want to connect. I'm going to connect to localhost. Yeah, hang on. Why is it not working? Sorry. Open. Okay, so down here you can see that it's connecting. We're connected now to localhost, which is where my container is running. Now, if I run this command here, it will show me all of the data files that are associated with this backup. And you can see that, in fact, these backup files originated on Windows, right? So now what we're going to do is we're going to restore this backup to Linux. And again, keep in mind that this has all of the most advanced features of SQL Server running inside of it. So there you go. Just finishing up the restore right now. But this is probably the easiest way to migrate from SQL Server on Windows to SQL Server on Linux. You just do a backup and a restore. You can also do a detach and attach. You can use SQL package to create a backup file or a DACPack file. Either way, you can deploy easily from SQL Server on Windows to SQL Server on Linux. So there you go. It's been restored. Now, what I want to show you is kind of another interesting scenario here where I want to use Docker Compose. So in this particular application, I've got Docker Compose set up to where I have multiple containers involved in providing an image. So I've got the voting application, which is a Python-based application. I've got a Redis container that allows the user to vote on dogs versus cats. The vote gets stored in the Redis container. Then I have a Java worker container that copies the vote from the Redis CacheDB over to the SQL Server database container, which in this case is running MS SQL Server RHEL. And then it'll display the results using a node-based application. So let's go over here. Kill that last container. And we'll just do Docker Compose up. And this will start up all of those 5 containers all simultaneously. And the containers will connect up to the corresponding databases they need to be connected to. And once we do that, then we can see the application inside of the browser, and we can vote on dogs versus cats. So while we're waiting on that to come up, quick show of hands. Dogs? Cats? Okay, dogs win, as always. All right. Okay, so here's our dogs and cats. We're going to vote on dogs. And here's our docs, right? So this is a quick example to show you how SQL Server can run in a container. It can be part of a Docker Compose application. It works with Python and Node and Java. Works with any language you want. And in this particular case, I'm using the for JSON auto functionality in SQL Server to actually query the database, return the results back in JSON format, and simply pass that directly through to the front end where it's rendered. All right. So let's do one more demo. So okay, so first I'm going to create a new project up in OpenShift. Okay, so I've already got my project up there. Okay, so here's my day trader demo. Okay, so I don't have anything in it. Now I'm going to replace a few of the different container images there with kind of the most recent ones for JBoss. So this is the day trader demo app. It's kind of canonical in the JBoss Java world, right? And now I'm going to simply deploy that application up to OpenShift. So this will push my application up there. And you can see that now everything's kind of coming in there, including the MS SQL Server image here. So just given the time, I'm probably going to skip over this part of the demo. But the idea with this is that I can push SQL Server containers as part of an application up into OpenShift. And there's lots of different ways of doing this. This is just one particular way. This project is available up on my GitHub as well if you want to take a look at it as a sample for how it can run. But the next thing I want to show you is just kind of our last demo here, which is using Active Directory authentication. So as I mentioned, this is sort of like the risky, hope it works last demo here. So here we are. I'm SSH'd into a host up in Azure, and I am going to connect over to a SQL Server instance. Now in this particular case, you can see that I'm SSH'd into this machine using an Active Directory ID, travis@addemo.com. So this machine is already domain joined. It is a Linux machine, obviously, because I'm SSH'd into it. But I'm logged in using an Active Directory identity. Now, to begin with, I connected here using a SQL login, to ADDemo MS SQL using this user SQL admin. And I'll run a quick select add version here and show you that, in fact, this is a SQL Server that's running on Red Hat Enterprise Linux. And now what I'm going to do is I'm going to create a login called ADDemo Travis from Windows. Now, this from Windows syntax will go away. We'll kind of clean that part of it up. But I've created my login now, and I can do a select name from sys.server principals. What do I do? Oh, principals probably. Okay. All right, so there you can see the ADDemo Travis underneath there, right? So this is now a login that's available for authenticating with SQL Server. So we'll quit out of this now. And this time, when I connect to the server, I'm not going to use the SQL login. I'm going to use the identity that I'm logged in with currently. There you go. I'm connected. Right? So just like that, I'm able to authenticate using Active Directory identities against SQL Server running on RHEL. So let's go back to the slide deck now, and I will just wrap up here quickly with a last couple things here. Okay, so the road ahead. We are in the community technology preview phase now. We just released CTP 2.0 in the middle of last month. That is our production-ready release. We have customers that are in our early adoption program now that are already in production using SQL Server on Linux. And we're targeting a second half of this calendar year as the final general availability release of SQL Server on Linux. So as I mentioned, we have this early adoption program. If this is something that's interesting to you, is to actually start using SQL Server on Linux in production prior to general availability, please sign up at this link here. And we would be happy to support you in that. So we have Microsoft support standing by. They're fully trained, ready to support you 24/7 with the SQL Server engineering team standing behind them to make sure that your applications run smoothly in production. And for the preview period, there's no cost to doing that. And you can get started right away. The only thing that's required is an NDA, which a lot of companies already have with Microsoft. And then lastly, these are all the things that I demonstrated to you and more. You can go and grab these things and kind of try them out for yourself. And with that, I will end this speed session. Hopefully I didn't talk too fast, but I had a lot of information to convey to you guys. I hope it was an interesting session. And I'll be available up here afterwards for any questions you might have. So thank you.